Good morning, friends. Last class we studied some sample space examples. So today also we will study sample space examples. Now, dear students, this is one of the best example of sample space. A coin is tossed. When a coin is tossed, so just I will write here coin. If it shows head, we draw a ball from a bag consisting of 3 blue and 4 white balls. If it shows a tail, we throw a die. Describe the sample space of this experiment. Listen here. This is one of the best example experiment of the sample space here. We can see. See here, what a coin is given. When a coin is tossed, one time means we get what a head or tail. If head will turn up means then the bag consisting of 3 blue and 4 white balls. If it shows a tail, we throw a die. So first of all, I will write here coin. Next here we will get what are 2 result now. So first one is head, and next is the tail. So head is turned up means next here one bag is there. This bag contains 3 blue balls. So I will be indicating B1, B2, B3. See, 3 blue balls is there, so that's why I will be indicating B1, B2, B3. Next, 4 white ball is given now, so that's why I will write here W1, W2, W3 and W4. So totally this bag contains 7 balls, 3 blue balls and 4 white balls. And next, if it shows a tail, then when you toss the coin, you will be get what the tail is. If the turn of the tail means then we threw a die. So then die totally 6 possibilities there. 1, 2, 3, 4, 5 and 6. So totally 6 possibilities there. So with the help of this concept, we can write the sample space. Okay. So this is not necessary to write. Just for it is for your clarity purpose. I wrote here solution. The sample space of a experiment is yes equal. Listen here, when a coin is tossed one time, then you will get what a head. When head is turned up, then we draw a ball from a bag consisting of 3 blue and 4 white balls. So now I will write here H B1, H B2, H B3. Or next H W1, H W2, H W3, H W4. Next coin shows a tail, we throw a die. Next time right here T1, T2, T3, T4, T5, T6. So totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So totally 13 elements will come. Totally 13 sample points will come here. Right. Okay. Dear students, the next question is, consider the experiment in which A coin is tossed repeatedly until a head comes up. Describe the sample space. Describe the sample space. Now, listen here. Consider the experiment in which a coin is tossed. You take a one coin, you toss the coin, then you will get what head, or otherwise you will get what tail. Until a coin is tossed repeatedly until a head comes up. A head comes up. So means what is the sample space of the given experiment is? Now solution it is, I will write here S equal to the sample space of the given experiment is S equal to. First one you will get what head, next tail head, next tail head, next tail head. So that means infinity number of possibility will come here. Infinity number of possibility will come here. So this is your sample space of the given experiment. Okay, right. Now, so these are the examples of what sample space. So in previous class only we studied about these concepts only. So now the next concept is very important. It is so that is events. So in the last class only just I discussed only definition. Now today we must discuss events, types of events, algebra of events. Okay, dear students, let us will see event. What is meant by events? Any subset of any subset of a sample space in a random experiment. Any subset of a sample space in a random experiment is called event. It is called as what? Event. It is. Okay. Now, example. I am right here. When a coin is tossed, two times. Then the sample space is S equal to 1, 2, 3, 4, 5. Sorry. Sample space is head, tail, head, tail. Okay, so totally 4 possibility results will come here. Totally 4 possibility results means HH, HT, TH, TT. This is the sample space. What is the events? Events is nothing but what? Any subset of a sample space in a random experiment. Means here I am taking E1, HH. Here I will be taking E2, HT, TH, TT. So E1 and E2, these are subset of the given sample space. Yes. See, can we say E1 is a subset of yes? Exactly correct, because this HH is an element also present in the given sample space. Yes. Next, can we say E2 is a subset of yes? 100%. So all these elements are also in E2. E2 contain HT, TH, TT. These three elements all are present in the given sample space. Yes, so that's why E2 is also subset of S. So it shows that what is the meaning of event? Any subset of the sample space in a random experiment is called the event. Is called event. So these two are example of the given event. Okay. Right. Next. Now, event is over. So in the events, we can say some types. So here also we will see here types of events. So in the types of events, dear students, so first of all we must see first one is a sure event. Second one is compound event. Third one is simple event. And fourth one is impossible event. Okay, dear students. So totally we can see four types of events. So first one is sure events, second one is compound, third one is simple, and fourth one is impossible events. So sure event is nothing but the whole sample space. Yes, is called sure event. What is the definition of a sure event? The whole sample space yes is called as what? Sure event it is. Means you can take whatever the sample space element is there. So in this event also contain all same elements. Okay. So in this condition, in this events, we can we can call it as a sure event it is. Okay. Next, compound event. Compound event is nothing but if an event contains more than one possible or otherwise we write more than one sample point. What is the definition of a compound event? If an event contains more than one sample point, is called as what? A compound event. Is called as what? A compound event. Next, the simple event. If an event has only one sample point. If an event has only one sample point, is called as a simple event. Is called as what? A simple event. And impossible event. The empty set phi. The empty set phi is called as what? A impossible event. The empty set phi is called as what? A impossible event. So these are the types of events. So once again I will explain these four events. Sure event is nothing but what? The whole sample space yes is called as what? Sure events. Compound event is nothing but what? If an event contains more than one sample point it is. So more than one sample point is called as what? Compound event. Simple event is nothing but what? If an event has only one sample point, is called as what? Simple event. And impossible event is nothing but the empty set is called as impossible event is. Right. So let us discuss these concept related examples. So these are the definitions. Now we will discuss examples. Okay. Dear students, just I will be taking here one example. When a coin is tossed, two times, then the sample space is yes equal to. Listen here, when a coin is tossed two times means then we will get what the sample space four elements HH, HT, TH and TT. Okay, so these are the sample points of the given sample space. Okay. Now, how to explain sure events? Now I told sure event is nothing but what here? The whole sample space is nothing but what a sure event. So I will write here E1, HH. So E2, HT, EH, E2, E3, HH, HT, TH, T2, and E4 for all. Okay, dear students, listen here. These are the examples of what the types of events. So first one is this is the sample space. This is what the sample space. So the first one is the E1 contain only one element. So only one element is nothing but what if an event has only one sample point is that means we call it as what a simple event. It is simple event. So we call it as what a simple event. So this is the example of what a simple event. So you can take anyone, not only HH, you can take separately HT, TH, TT. You can take anyone. Just I taken here HH, one example. Okay. So this is what a simple event example. Next, see, HT, TH, TT is there. So three element is there. Three sample point is there. Means what is the compound events? Compound event is nothing but if an event has more than one sample point is there. So now here more than one means here three is there. So can we say this is a compound event? Yes, 100%. This is a compound event. This is not a compound event. Okay, next third event E3. This E3, check it, verify. In sample space, so total is 4 element is there. In E3 also same element and also 4 element is there. So that's why can we say this is a sure event? Exactly, sure event it is because it contains same and the whole sample space. Yes, is nothing but what is sure event. Now, next, last one is empty set is there. Can we say this is impossible? This is impossible event it is. So these are the examples of types of events. So these are the examples of types of events. Okay. So right. Now, next we go to algebra of events. Dear students, already we were studied in the set theory chapter. There also we studied algebra of sets. So their union, intersection, and difference, complementary sets. So these type of sets we studied in the set theory chapter. Similarly, likewise, we will be studying here also, but we must study with the events. Okay. Now, next concept is algebra of events. So, algebra of events, we can see first one is complementary events. Second one is events A or B. Events A and B. Events A but not B. Okay, dear students. So these are the algebra of events. First one is complementary event. Complementary event means so this we can express it not a form. Okay, so we can write even not a also. Not a is nothing but a dash equal to yes minus a. Yes is nothing but what a sample space. So minus is the difference of a digit. Whatever the given event will be given. So yes minus a means whatever the result will come, the result we consider what a dash. It's a complementary event it is. And the next one is events A or B. Events A or B means so now we must write always A union B is the event of A union B. The events of A union B is. So this one we call the order A or B. And events A and B is given. Events A and B is nothing but A intersection B is. A intersection B is. And the last one is events A but not B. A but not B means A minus B is. A minus B. Or otherwise we can write even A intersection B dash. A intersection B dash. So these are the events we call it as the algebra of events. So first one is a complementary event. We must always denoting not A is, or otherwise we can express it like this: A dash equal to S minus A. Okay. Next, events A or B is nothing but we can write event A union B is. Next, events A and B is nothing but A intersection B. So already you are studying in the set theory. Union is what all the set A and set B. The combination of set A and set B elements we must write only one time. Okay. In the intersection condition, already you know the common elements of given two sets. But here events, we are studying the events. Okay. So in the set theory, already you are studying intersection is nothing but the common elements of the given two sets that will be called as the intersection. Okay. Next, events A but not B is nothing but A minus B or A intersection B dash. Okay. So this is the algebra of events, very important concept. Now we will be discuss some examples of these concepts. Then only you will get the idea. Okay. Right. Consider the experiment. Experiment of rolling a die. Let capital A be the event. Getting a prime number. B the event. Getting an odd number. Write the sets representing the events. First one is A or B. Second one is A and B. Third one is A but not B. And fourth one is not A. Okay, dear students, this is a good example of algebra of events because all the concepts covered in this problem. So let us we will discuss. Now listen here. Consider the experiment of a rolling a die. So die is given. So when a die is rolled one time, then what is the sample space element will come? So totally 6 sample space sample quantity is there. What are those? 1, 2, 3, 4, 5, 6. So first of all, we will write here solution. Here S is given. What is S? Sample space. So die is given. Experiment of a rolling a die is given. So we will write here 1, 2, 3, 4, 5, 6. 1 to 6 elements. Let capital A be the event getting a prime number. So here set A is given. Getting a prime number is given. So 1 to 6 numbers. What are the prime numbers here? Out of 1 to 6, what are the prime numbers? So 2, 3, 5. So we will write 2, 3, 5. Okay. 1 is not a prime number. Okay. So 2, 3, and 5. These 3 elements are prime numbers. Out of 1 to 6 numbers. Okay. Next one, B be the event. So getting an odd number. Getting an odd number is given. So 1 to 6 numbers. What are the odd numbers? 1, 3, 5. So we must write here 1, 3, 1, 3, 5. So totally 2 events is given, and here condition. What is the first one? What is the first one condition? A or B is given. A or B. Now I told or is nothing but what? Union it is. A union B it is. Now check it. A union B. A union B is nothing but. So repeated terms is not allowed inside it. So we write only one time. So what are those elements? Just you write that. Combine these two sets, you will get 1, 2, 3, 5. So 1, 2, 3, 5. These 4 sample points will come. Okay. Next, second one. What is second one? A and B. A and B equal to A intersection B is given. A intersection B is given. Intersection means just we must write the common elements. What are those? So here 2 is there, there is no 2 here. Here 3 is there, here also 3 is there. Here 5 is there, there also 5 is there. Means here common elements 3, 5. A intersection B is there. And the third one is A but not B. A but not B. A but not B is nothing but A minus B. A minus B. Now you write directly. See, A minus B means remove the common term, remove the common element except a different term. Means a different element. Means, see, here 3, 5 is there. Here also 3, 5 is there. Okay. A minus B is nothing but remaining the common term. Whatever the remaining element is there, so those numbers, the result of A minus B. The result of A minus B. Here only one element is there, that is the 2. Right here. Next, fourth one is not A. Not A. Not A is nothing but the A dash. A dash is nothing but the S minus A. So S minus A means here 1 to 6 element is there, minus of 2, 3, 5 is there. So remaining result will come out 1, 4, 6. 1, 4, 6. So this is your good example of the given experiment. Right. Now, so next we go to another problem. So it is also a similar type of a problem is there. Dear friends, so whatever the problems is there, so you must practice one time daily. So then only you will get what the correct idea about these problems. Okay. So if you not practice, please you can't understand the concept. So practice in your own. The next question is, a die is thrown. A die is thrown. Describe the following events. Condition is given. A number less than 7. B, a number greater than 7. C, a multiple of 3. Next one, D, a number less than 4. Less than 4. E. And even number greater than 4. Yeah. A number not less than 3. Also find A union B, A intersection B, B union C, E intersection F, B union E, intersection of this. Next, A minus C, B minus E, E intersection F dash. Okay, dear students, it is also a very simple concept. It is a die is a thrown. So here also a die experiment is given. So the samples point 1 to 6 elements will come here, and describe the following events. So here in the wording form is given. Thus we must write in a set form, event form. After that we must define these conditions. Now let us will say one by one. Solution. Firstly, I will write here sample space. Here we are simple. We will write 1, 2, 3, 4, 5, 6. This is the samples space of the given experiment. Okay. Now, E. Okay. Event A is given. Event A number less than 7 is given. Number less than 7 means, see, in sample space 1 to 6 numbers is there. Less than 7 means we must write those numbers only. Means we must write 1, 2, 3, 4, 5, 6. Next, B. A number greater than 7 is given. A number greater than 7 is given. Dear students, greater than 7. Say in the sample space there is no more than 6 numbers. There is no more than 6 numbers here. The number greater than 7 is given. So there is not that type of number. So that's why we will write a empty set for all. Right? 5. Next, you write C. A multiple of 3. C event is given. A multiple of 3. So multiple of 3 means what are those? 3, 6. Next, D. A number less than 4. A number less than 4 means what are those numbers? 1, 2, 3. Next, E. What is A? An even number greater than 4. An even number greater than 4. Nothing but only one element, that is 6. A number not less than 3 is there. F. A number not less than 3 is given. So that's why I write here 3, 4, 5, 6. See, listen here, dear students. A number not less than, not a less than, not less than 3 is given. Means, so less than 3 is nothing but what? 1, 2 only. So 1, 2, these two are elements of less than 3. But here, not less than is given. So that's why we must write 3, 4, 5, 6. 3, 4, 5, 6. So these are the conversion of the given events. Okay. One term is over. Next is we must find A union B, A intersection B, B union C, E intersection F, D intersection E, A minus C, D minus E, E intersection F dash, F dash. Okay. Let us see one by one. So first one. What is A union B? I will write here directly. A union B. So A contain 1 to 6, B contain empty set. So what is the combination of these two sets? So here also empty is there, here 1 to 6 numbers is there. In union operation, we must write 1, 2, 3, 4, 5 and 6. It's over. Next, second one, A intersection B. A intersection B. See, A intersection B condition. See, here empty set is there, here 1 to 6 numbers is there. There is no common element, so that's why we get what empty set. You write point. Next, third one is B union C is given. So B union C here empty set is there, here 3, 6 is there. So result will come 3, 6 only. 3, 6. Next, fourth one, E intersection F is given. E intersection F. E contains 6 elements, F contains 3, 4, 5, 6 elements. So means what is the common element here? Only one element, that is 6. Next, fifth condition, D intersection E. D intersection E. So 1, 2, 3 is there, and E contain only one element, that is 6. There is no common element, so that's why the result will come empty set or fine. Next, the sixth one is A minus C is given. A minus C is given. So A contains 1 to 6 elements, C contains 3, 6. So remaining what are those elements? 1, 2, 4, 5. These 4 are the element of A minus C. And the next, seventh one, D minus E. So D minus E. D contains 1, 2, 3. E contains 6. So there is no common element. So just we will write 1, 2, 3. Next, eighth one, E intersection F dash. E intersection F dash is nothing but, if you perfect means you write directly, or otherwise E intersection F dash is nothing but E minus F it is. E minus F. We can write E minus F also. So here, what is the common? What is the result? Here 6 is there. There is no common element. So finally, you get what F intersection. And lastly, ninth one, F dash is given. So F dash, nothing but 3, 4, 5, 6 means we must write S minus F. So F contain 3, 4, 5, 6. S contain 1, 2, 3, 4, 5, 6. The result will come 1, 2. 1, 2 is F dash is. So these are the conditions of the given example. Okay, now you write. Okay, dear students, once again I will explain this one. The condition is given, a die is thrown. So die is thrown, condition is given, the sample space element will become 1, 2, 3, 4, 5, 6. Describe the following event is given. So totally A to F conditions is given. So these A to F are events it is. So first A event is a number less than 7 is given. A number less than 7 is nothing but, I wrote here, A contain 1 to 6 sample point. Next, B event is given, a number greater than 7 is there. So in sample space 1 to 6 number is there is no more than 6, but here greater than 7 is given, so there is no elements of that type of numbers is not there now, so that's why we will write a empty set it is. Next, see, a multiple of 3 is there. In 1 to 6 numbers, the multiple of 3 is 3, 6. So 2 elements will come. Next, D. The D event, a number less than 4 is given. Less than 4 means 1, 2, 3. 3 elements will come. Next, event E, and even number greater than 4 is given. Greater than 4 is nothing but what? Only one element, that is what 6 is. And Lastly, F is given, F, a number not less than 3 is given, not less than. See, dear students, don't get confusion here. A number not less than. A number less than 3 means we can take order 1 to 1. But not less than is given, so that's why we will write 3, 4, 5, 6. So this is the F element result. So one part is over. And the next is also we must find A union B, A intersection B, B union C, B, E intersection F, B intersection E, A minus C, D minus E, E intersection F dash, F dash. So these are the results of the given conditions. Okay. So A union B means union of these two events, then you get what 1 to 6 result. Then A intersection B means you will get what the empty set. B union C means you will get what the two elements, that is 3, 6. E intersection F means 6. D intersection E means empty set. A minus C means 1, 2, 4, 5 these. And the next D minus E means 1, 2, 3. And E intersection F dash means we can write E minus F also. We get what empty set. F dash equal to S minus F equal to your result will come 1 to 1. So these are the examples of the algebra of events. So today is enough. So remaining next class I will come. Thank you.